Hello everyone, welcome to Link and Learn. Today we are going to discuss the selection sort. For a given array num with some values in it, using selection sort, you have to select a particular value based on which you will be sorting this array in ascending or descending order. Let's see the logic. We are assuming that the array has two sections, the sorted part and the unsorted part. I'm introducing a new variable called as I, which keep track of or starting index position of the unsorted array. And I'll be introducing another variable j, which is used to iterate through all the values in the which is used to iterate through all the values other than the starting value in the given array. So in this case, the entire array initially is considered as unsorted array. I'm introducing another variable mi, which keep track of the index position where you have the smallest value. Why I am choosing the smallest value is because I want to select and sort this array in the ascending order. So initially I'm assuming that the first item in the unsorted array is the position where you can find the minimal value. So minimum value, index position and I both are pointing to 0, which is representing the value 8. And then j will start moving from I plus 1 value, the immediate next value 5, to the end of the array. And every time the value at jth index will be compared with value represented by the minimum value index position. So right now j is pointing at 10. So 10 and 8. 8 is the smallest value, so no change. So j will go to the next position. 2 and 8. So 2 is less than 8. So that means you will be updating the minimum value index to 2. The process continues. J will go to the next value. You have 5 and the minimum value index position points 2. 2 is less than 5, so no change. And then j will go to the last value where you have 9. 9 and 2, no updation. So now you have the minimum value index position pointing to 2 and the starting point of the unsorted array as 8. So you will swap the starting point index position value and the minimum index position value. So the new array will be 2, 10, 8, 5 and 9. As you can see, now 2 is placed at the right point where it need not be changed at all. So this is the sorted array and this is the unsorted array. We repeat the same process. I will be pointing here the minimum index position also assumed as the first value in the unsorted array. J will be starting from immediate next value. So every time you will compare the value pointed at j and value pointed by mi. So 10 and 8. 8 is smaller, so you will update mi to 8. And then j will go to the next value, which is 5. You will compare value pointed by j and mi, where you have 8 and 5. That means 5 is a new smallest value. So mi will be updated to 5. And then j will go to the last value, where you have 9. And when you compare 9 and 5, there is no change. So you have the minimum index position identified at this particular location, and then you are supposed to swap the I and j. So after swapping, you get 2, 5, 8, 10 and 9. As you can see, at this point, these two values are properly arranged. So this is the sorted array after this iteration, and then this is the unsorted array. So we repeat the same thing. I starts here. Mi also point to the same location. J starting from the immediate next item. So you will compare J and Mi values, 10 and 8, no update. So J will go to the next item which is there, 9, 9 and 8. 8 is still the smallest value. So the Mi and I will be swapped, but even after the swapping, the value remains the same. And then the new array will be 2, 5, 8, 10, and 9. And this time, this three items are properly sorted, and these two items are unsorted. And the step remains the same. I is the new beginning index. Mi, assuming that the first item is the smallest item, and then j starting from the immediate next value. At this particular point, we will compare 9 and 10. That means Mi should be updated to the new one, and you will swap Mi and I because there is no more value to be considered. So after swapping, the new value will be 2, 5, 8, 9, and 10. You cannot move further. That means I should be moving only till the second last element. At this particular point, you should stop. If I go to the last element, j has to start from the immediate next value, where we don't have any immediate next value if I go to the last element. This is the logic for selection sort. This is the pseudocode which represents the selection sort. As you can see, I is the looping variable which keep track of the index position of the starting value in the unsorted array, which starts from 0 and go all the way to n minus 2, where n is the size of the array. Minus 2 will give you the second last element. And then every time I'm assuming that I is the index position where I have the minimal value. And then J loop keep track of the iteration from the immediate next value all the way to the rightmost value. And if there is a value num of j which is less than the current value pointed by the mi index position in the array, then using these three statements we will do the swapping. For example, if a is the value which is pointed by I and mi is the value pointed by c, I will use a temporary variable in order to swap the value. So temp is equal to num of I. That means a is now copied to temp, right? So there is a vacancy here. And next step says that num of I is equal to num of mi. That means whatever value is pointed by m of I will be copied to I. That means C will be copied to I. That means here you have a vacancy. And in the last step, num of mi is equal to temp. That means temp will be copied to the index position pointed by mi. That is, A will be copied here. This is the swapping operation. Thank you.